Good morning. This is your Stat Sensei, Mr. Spensei, and this is Geometric Probability, the honest guy at school. So first off, please note, geometrics are generally formed. What is the probability the first success will occur on a specific trial, which means it's going to happen on the third time or the fourth time or the fifth time, but we have a specific number, in which case we're just going to run a straight geometric PDF. On the other hand, what's the probability the first success will occur no later than? So within a group. If it's within a group, we're going to have to go to the summation. All right. On the other hand, what's the probability that will occur after, or it'll take at least this number of tries? If it's after or more or at least, we're going to have to do one minus the summation of the geometric PDF. All right. So let's try this out. Suppose only 17% of the guys at some high school are honest. So our probability is 0.17. Okay, we don't know anything else yet. So I know this. It's binary, 17 per honest. The rest are not honest. Each one is independent, and the success level stays the same. But that's all I know at this point. Then it says, what's the probability the first honest guy that a new girl meets at school is the third guy she meets? So we're looking for the first. As soon as we're looking for the first, this lets me know that this is uh, a geometric, and that means my number line is going to start on one. So my number line is going to be starting on one. So I'll go ahead and start this off. One, two, three. And really, I'm stopping at three because I'm looking for it to occur, the first honest one to be on the third one. So let's go ahead and look at our sentence that we have to do. Let X equal the number of guys until we meet or find the first honest guy. So let X equal the number of guys she meets until she finds the first honest guy. All right. So that tells me real quickly that it's a that we have a geometric because of the word first. We're looking for the first. It's almost guaranteed to be geometric. There's my graph 1, 2, 3. We're looking for the third one. Our p-value we identified as 0.17. We don't know how many trials it is, but we know that we're trying to find our success on the third one. Well, since I only circled one value, that means I'm coming down this one. So we want the probability that X equals 3. So my probability statement is purely going to be the probability that X equals 3. I'm going to go ahead and write my formula. My formula is 1 minus P to the X minus 1 times P. So 1 minus P to the X minus 1 times P. Well, plugging in, the probability of honest is 0.17. So 0.17, X is 3, so 3 minus 1. And this is supposed to be, let me start over on that. I made a mistake. It's supposed to be 1 minus P, so 1 minus 0.17 to the 3 minus 1 power times 0.17. All right. And by the way, you could have just written 0.83. So at that point, we've already plugged into the formula. So all we have to do is run our test. So second vars, geometric, PDF, probability 0.17. Our X value, we're looking for X, we said was the third one. And we end up getting 0.1171. 0.1171. Now, we've done this type of work in classical probability. In this case, we said that we were going to have three. 1, 2, 3. This is the honest guy. So liar, 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 and then honest. Well, liars are 0.83. And you can see real quickly when I go 0.83 times 0.83 times 0.17, we get the same thing, which is what we would have done in classical probability, but it ends up being the same thing as a geometric. What's the probability the first honest guy she encounters will be no later than the third guy she meets? So let X equal the number of guys she meets until she finds the first honest guy. I'm not going to redefine it. I'm going to try to save time. But I do have to make my number line, which is 1, 2, 3, and said will be no later than the third guy. So it could be the first guy, the second guy, or the third guy. Please remember, geometric start at 1. Binomials start at 0. Geometric start at 1. Well, I circled more than one value. All right. So I circled more than one value. So I need to write my summation. Write the probability statement, the lowest value, the highest value. So my probability statement is going to be the probability. My lowest value is 1, less than or equal to X, less than or equal to 3. So that's my probability statement. Then I need to write my formula. My formula is going to be the summation of 1 minus p to the x minus 1 times p. So parenthesis, summation first, 1 minus p to the x minus 1 times p. Now, please remember, I have that summation purely because I have more than one values, and that's consistent with what we did before with the geometric. So now I'm going to plug in. And we have to do the lowest value and the highest value. So we're going to go 1 minus 0.3 to the x minus 1. So 1 minus 1 times p to the first, because all I did was plug in this value everywhere I had an x. I plugged in 1 wherever I had an x. Excuse me. 1 minus 0.3 to the 1 minus 1 times, it's not 0.3. I'm so sorry. Hope I haven't confused you. The probability, I should have written this down so I wouldn't mess it up, but I was trying to be fast and that took longer. The probability that she meets an honest guy is 0.17. So 1 minus 0.17 to the 1 minus 1, because that's the first value we circled, times 0.17 to the first, plus dot, 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 plus 1 minus 0.17 to the third, because that's 3 is the highest value, minus 1, times 0.17. And we really don't even have to put this to the first, but technically it's to the first right here, but we don't even have to write it. Okay. So there's my work shown, and I'm sorry I didn't do a very good job on that. Hopefully I'll get it better on the next one. With summation, and we don't even have to have that summation sign. So what you do have to have, and I'll rewrite this, 1 minus 0.17 to the 1 minus 1 times 0.17 plus dot, 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 plus 1 minus 0.17 to the 3 minus 1 times 0.17. There we go. That's a lot better. Now notice this 1 was here. This 3 came from there. So now this is a summation problem because we have multiple values. So it means I'm going to have to go to the math button, drop all the way down to summation, and press the X button. In this case, I started at 1, and I went all the way up to 3. Second vars, geomet, PDF, probability is 0.17, X value is X. Because remember, anytime you use the summation button, that needs to be an X, and we're pressing enter, and we get 0.4282. Because basically we took the summation of 1 plus the summation of 2 plus the summation of 3. All right, what's the probability the first honest guy she'll meet will be among the first 3? Well, that's exactly the same thing as what we just did. No later than the first three means it had to be in the first three. That it's among the first three. That's exactly the same thing. So there's my number line. My probability statements, the probability is 1 is less than or equal to x is less than or equal to 3. We've already defined x. We said x is the number of guys she has to meet until she finds the first honest guy. My formula is the summation of 1 minus p to the x minus 1 times p. When I plug in, I have to do the lowest and the high. So we're going to go, and our probability is 0.17. So 1 minus 0.17 to the 1 minus 1 times 0.17 plus plus 1 minus 0.17 to the 3 minus 1 times 0.17. And even though we just did it, we'll do it one more time because math drop down to summation x 1, highest value was 3, second var's geometric PDF, x value is x. Because it's the summation, you have to have x there. And of course, we get the same value because it's exactly the same problem, just expressed slightly differently. So 0.4282. What's the probability she has to meet more than 3 guys in order to meet the first honest guy? Well, more than 3 means I'm looking for, it could be 1, 2, 3, all the way to infinity. Excuse me. 1, 2, 3, 4, 5, all the way to infinity. So this becomes a more difficult problem. All right. First off, if we have, in this case, we're looking for the probability that x is greater than 5. Well, the calculator can't go to infinity. So we have to do something different. We have to do 1 minus the probability that x is less than or equal to the highest value not shown. So 1 minus the probability that x, what's the highest value not shown? Is 4, is less than or equal to 4. All right. So because this is the part, this is what we wanted. So we're going to have to subtract out what we don't want, which is everything below that line. So 1 minus the probability that x is less than or equal to 4. That's our probability statement. What we're going to write for our equation is 1 minus the summation of what we had before. What we had before was x minus p, 1 minus p to the x minus 1 times p. I'm going to put all that in brackets. So I'll rewrite it one more time. 1 minus bracket summation of 1 minus p to the x minus 1 times p. And I'm going to close those brackets. Okay. So in this case, I got to plug in. So 1 minus, and remember, we're always going to plug in starting with our lowest value, which happens to be 1. So 1 minus bracket. And we're going to have 1 minus 0.17, 1 minus 0.17 to the 1 minus 1 times 0.17 plus plus 1 minus 0.17 to the fourth minus 1 times 0.17. And we're going to close our brackets. So it should look something like that. So in this case, I'm going to go 1 minus parenthesis. Actually, I don't even have to do that. 1 minus the sum math summation. So 1 minus the math summation, x. The lowest value we had was 1. The next value we had was 4. That was the highest value that was left off. Second vars, geometric, PDF, probability is 0.17, and x stays x. So that's 0.4745 is our answer. Now let me go back and look at this one more time. I just want to point something out to you guys. So 0.47, 0.45. If I hadn't put the 1 minus in front, I would have been finding the probability of getting 1, 2, 3, and 4. So let's do that real quickly. Math, stat, our summation, x, 1, 4, geometric PDF, second vars, geometric PDF, everything's there. And that's the probability of 1 to 4. And if I take 1 and subtract that, I get our answer. All right. So lastly, how many guys does she expect to have to meet to find the first honest guy? Well, the probability is 0.17. And the expected value for the geometric is 1 over p, which is 1 over 0.17. And 1 divided by 0.17 is 5.8823. So she'd expect to have to meet 5.8823 guys in order to find the first honest guy. All right. I hope next video is better, but I sure appreciate you sticking with me through that one. Talk to you later. Bye.